Hi there, I'm Anthony. I've been working on integrating PhysX 3 into Unity 5.0 for the last year. So today I have some interesting stuff to share with you. Yeah, so let's get started. Yeah, so today's talk is going to come in two parts. First, I'm going to use the opportunity to talk about myself and my experience overall, and then about my daily activities at Unity. And after that, we are going to dive right into the components overview. And I will use this time to show you what's changed with the Unity 5.0 and the PhysX 3. But then I would like to keep it really simple. So if you are going to hear something about complex stuff like tensors or complex pruners or anything else, that is going to be next time. So I'd like to make it so that the audience who is there to listen to something simple and introductory will be satisfied, okay? Yeah, there would be some, wow, people still come, fantastic. So much interested for physics today. Yeah, good, and there will be some summary after all. Yeah, so about my experience, so you know, I've got most of my experience programming for consoles, and I've spent 6 years writing stuff for the previous generation, like for Nintendo DS and PlayStation 2 and that kind of stuff, pretty old one. So I've been responsible for collision detection back then, for some really basic physics, you know, and for visual effects as well. So yeah, we had some pretty successful ones, like the American Chopper. That was a pretty successful title. We sold about 1 million copies in discs on PlayStation 2, so that was good. Yeah. So I've joined Unity about a year ago to work on the long-awaited PhysX 3 integration. And yeah, I'm going to talk about the history of that a little bit later. But my daily activities really include fixing the bugs, since we have tons of bugs still. And I'm the one who really decides whether or not we want to include that feature or that feature in PhysX. Yeah, and yeah, I'm also responsible for planning and for talking to you developers to figure out what are the main problems right now and what should we fix right now, whether we need to rush with the fixes or not as well. Yeah, that's probably all about me. So yeah, another interesting thing is that when I've decided to step away from the console business and take a look at Unity, I've decided that I want to have my pet project in Unity, and that was of course about physics. So that was a pretty simple game about ball bouncing from the walls, but you know, that were pretty quick balls, so I had to use continuous collision detection, and that never worked right. So there were a lot of, you know, non-physically realistic bouncing and that kind of thing. So I had to come up with my own implementation for that, and that led me to Unity team. So that was also nice. Okay, so just a few words about history of the physics. So PhysX has been there for quite a while. It's been with the first versions of Unity. So the screenshot on the left is actually the Unity 1.0 on the Mac. So this is what the original 3 guys done, Joachim, David, and Nicholas. So that already featured PhysX. And that was back in 2005. And you know, the problem with the physics, you know, it was mostly that we didn't have enough resources to integrate new stuff and fix the long-standing issues and so on. So NVIDIA moved with the physics quite fast, and they've included new submodules and new subsystems and then changed behavior. But we were never really ready to pick that up. So that was just standing there and waiting for fixes, waiting for someone to fix. So the biggest update, I think, was in 2010, when we shipped Unity 3.0, which featured the upgrade from 2.6 to 2.8. And the current version, Unity 4.6, it actually features PhysX 2.8.3. It's not the latest version of 2.8 actually, since we had to make a lot of our changes. We had the source code license for PhysX, so we had to make a lot of changes in the code to support different platforms, for instance. Like, we've supported Tizen, and that was not originally supported by NVIDIA, and many other platforms like, WebGL. And also we had to fix behavior in PhysX, so we ended up with a completely not compatible PhysX 2.8, so we could not upgrade that. And NVIDIA announced and actually released PhysX 3 in 2011, so that was about 3 or 4 years ago from now. And we were in a really hurry always, so we didn't have enough resources to integrate that. And then NVIDIA guys showed up and offered help. So what they've done is they've taken Unity and integrated PhysX 3 into that. So they've written all the integration code. But then we still had to spend time on cleaning this up and fixing bugs, making it behave like Unity way, Yeah. So we didn't have that time either, actually. And another problem was that PhysX 3 was feeling like a completely different engine from PhysX 2. So we couldn't just upgrade that right in the middle of the release cycles. We were not going to break everyone's job. So we had to think carefully about the timeline. So we've decided that PhysX 3 will be in 5.0. Yeah, so this is where I've arrived. And yeah, so the good thing is that, it's 2014 now. It's almost 10 years from the Unity 1.0. And we have finally PhysX 3 supported in the closed beta group. It's not yet released to public, but we can say it's supported, so that's good. So today we are going to talk about PhysX 3 integration in Unity 5.0. So what does the new PhysX bring us? So it's quite a big change. And NVIDIA has taken all the best approaches, all the best algorithms from PhysX 2.8, and then rewritten the whole code base from scratch. So it's completely different. All the interfaces are different, all the classes are different, so everything is different, basically. So we can say it's like integrating a completely different physics engine, say Havoc or Bullet. That's it. Exactly the same stuff. But the new code base is much cleaner, I could say. Like with the old PhysX, we had some files like 15,000 lines, like one class, and then about a third of the lines was commented out, since that was a historic code, not really working anymore. And then some parts were just like not if def, but then like included in the sections, like if false, then something. It never gets executed anymore, but it's still there. And when you try to debug stuff, you still have to get through that. Yes, this function is never called, so I should skip it. Come on. So we no longer have that. It's now much cleaner. It's quite good, I think. So also they have new submodule. Oh yeah, they have a modular design now. So they have the core SDK and then modules. So the two modules I'm going to talk about now is vehicles, that is something for cars, trucks, and so on, and cloth module, which is basically for character clothing. And the part of the new design is the task-oriented approach. So basically the old PhysX was designed to be run in one thread. So we still have the opportunity to multi-thread things like cloth by creating a new scene, PhysX scene for each cloth instance, and then simulate that into different thread. But that's not a pure multi-threading, it's not a modern approach. So basically the new PhysX brings us the task-oriented design. So basically it's every time it needs to compute something, it It decomposes the big task into smaller subtasks, so we can move the smaller subtasks to different CPUs. So that's much better now. And the last thing is that, it's different code base, so it actually brings some compatibility issues. We really try to do our best to avoid that, and but it's not always possible. So you would really have to change your projects to make it work with the new PhysX. Next, so we've tried to make it look the same. So if you open Unity 5.0, you will notice that most of the components are still there. Not all of them. Like you can notice that we now have only one cloth, and there was interactive cloth and skin cloth before. So we no longer have those components, only one cloth. But rigid bodies are still there, and joints are there, and colliders are there. So the difference is in components now. What I'm going to do now is to go through the components and talk about the differences and the changes. So let's start with something simple. So the rigid body component. Let's start with the adaptive force. I have no idea if you know what that is, but I think the video is going to be available online with some thousands of people watching online, so I guess I should tell what that is. So adaptive force is something to compensate for the computational instabilities. Like imagine a pile of objects, like one box, and then you put another box on top of it, and then another box, and boom, right to the skies. So in the ideal physical world, the box stack would never collapse, since it's the ideal world. But in physics world, the computational error adds up, so there is some maximum height. After that, the stack would collapse actually. So PhysX featured something like a physical force to compensate for the computational instabilities, for the numerical error. That's really interesting stuff, to have a physical force to compensate for something numerical. And that really worked really well for demos. They had fantastic demos, but I think the typical feedback from the developers was that it doesn't really work in the real games, and it really plays against the content. So I think one of the major problems, the Kerbal Space Program is not that stable, and when you have a long rocket, you really need to tie the modules together, like put some ropes or like something like that. Is that the adaptive force plays against the contact there? So I think if they update to 5.0, it should be much better. So the difference now is that we have adaptive force disabled by default. So if you're still doing any demo, you can of course switch it on, but I think we should keep it off. That's the first change. Also, we have maximum depenetration velocity now exposed. Okay, so now what's that? So imagine two bodies interpenetrating each other. So that could really happen. It shouldn't happen, but that could really happen. And there is some velocity applied to make the bodies separate again. And the velocity is quite high, and there are some use cases where you want the velocity to be not that high. It's probably useful for Kerbal Space Program, and then for like something like shooters. Like imagine some characters running towards each other, and then they can really result in a colliding state if you apply some server-side data, and if you set the low maximum depenetration velocity, you would get the behavior where character colliders would be separated smoothly, not like boom, but smoothly. So that is now exposed. Now something technical. That's quite a complicated thing. But anyway, I think that this is very, very important. So I'll spend some time explaining that. So please bear with me. This is just to state that we have three types of bodies actually. So we have static, dynamic, and kinematic bodies. So what is a static body? So a static body is just a game object with the collider attached, with nothing else, like with no rigid body. It's just a static body. So when you have that, PhysX really thinks that nobody will never move the object, so it can optimize for that. Yeah. Next is the dynamic object. Is basically when you have a collider as well as rigid body. So this is the perfect case for physical simulation. It's just a regular object that could be simulated and could live in the physics world just perfectly. And then the kinematic body. So kinematic body is pretty much the same as dynamic body. It means you have collider attached as well as rigid body. But the difference is that you have the is kinematic checkbox ticked on. And the way you work with it is you don't want any simulation. You want just to reuse the collision from the PhysX. So you want to specify the position of the kinematic body pretty much every frame or so. Yeah, that's it. So static, dynamic, and kinematic bodies. So what is important about those bodies now? So there are some restrictions on the colliders which you could use with those bodies. We did not have those restrictions before, but we have to introduce those restrictions with Unity 5.0 since PhysX 3 no longer supports some cases. So yeah, obviously we can't support the cases that are not supported by PhysX. But overall, I must say that this is done for good reasons. So basically, when you had some certain combinations of rigid bodies and colliders, it would not work really well. Like there were some glitches, and sometimes the bodies would go one through another just because of the wrong configuration. Okay, so when you have static and kinematic body, you can basically use any type of collider we have. Like you can use primitive colliders and mesh collider with any kind of setting. But speaking about dynamic bodies, you can have only convex objects there. Of course, all primitive colliders are convex. And we have mesh collider, and a small checkbox is convex there. So when you have it, it's all okay, but you can't have concave meshes on dynamic bodies anymore. So that was really working not quite correctly. So that was working slow first, so there were performance problems. And the next thing is that there were some collision detection problems and inaccuracies. So PhysX decided that they really can't fix that. Most of the problems really come from the simple concept that it's pretty hard to detect whether something is inside of the concave mesh or not. So for convex mesh, it's pretty easy using some simple geometry, and for concave meshes, you really have to check against each triangle, so that takes time. And they had some optimizations which didn't really work quite right. Yeah, and so I would like to say that we have some plans to integrate automatic libraries which really take concave meshes and separate them into convex subsets. Like there is a really popular library, HACD, which we are going to integrate in 5X. So probably it's a little bit hard to make it into Unity 5.0, but for 5.2, I think it will be there, certainly. So yeah, that's it. Another thing about bodies is a story about static bodies. So I guess some of you seen the line in the profiler saying that moving static collider, expensive, delayed, cost. Yeah, so that was it. So every time you move static collider, there is a huge cost associated with that. Since PhysX has to rebuild the whole scene from scratch, well, not the scene, but the structure that handles the movement, the AABB trees. that was true with PhysX too. So now we have decided to change that. So now we are using the same structure to handle the movement of static colliders and dynamic colliders. That doesn't really mean that static colliders are now the same as dynamic ones. It's not even close. We still have a lot of optimizations for static colliders, so if you are pretty confident that this game object is going to be static and we are never going to move that, please make it a static collider. Don't make it dynamic or kinematic just because, oh, so Unity now has it free. Let's do it. No. But anyway, when you really decide to move, it's now basically free. Yeah, that's it. So I think the reason why we have done that is it has always been one of the most popular reasons for performance degrade. And we had a lot of complaints. We've been explaining that stuff for quite a while. We've talked about that on the conferences. We had, I don't remember, in 2012, I think, we had Jonas Esterhoff talking about that on the performance session. Well, yeah, so we had everyone talking about that, but it never worked. So we've decided to change that. Next. Triggers. So as you know, when you have a collider, there is a small checkbox there, is trigger. So when you add a trigger, there are the same restrictions as for dynamic bodies. Sorry. So with triggers, you can now only use convex colliders. That is basically all primitive colliders. And yeah, of course, convex mesh. So for instance, you can no longer have a trigger on the terrain collider. So we had some use cases for that, but unfortunately it's no longer supported. Yeah, so just two more things about rigid bodies. The thing I've started my talk with, the continuous collision detection thing. So yeah, collision detection, continuous collision detection, what it is all about. So the default collision detection algorithm is discrete. So basically we simulate the physics on the fixed frame rate. So imagine having a really fast moving bullet moving towards the sheet of paper. So if you detect collision based on the fixed frame rate, you can have a state where on this frame the bullet is on the right, and then on the next frame, since the bullet moves really fast, you have it on the left. So we skip the collision detection thing, so yeah, the collision would be missed. So we had continuous collision detection exactly for that. That is the kind of algorithm which really tries to simulate, say, in between the frames so that we will get the collision right at that point. But the problem with the continuous collision detection algorithm in PhysX 2 was that we had to supply something called CCD skeleton. So a skeleton was some structure like a bounding volume of the whole movement, which we needed to compute in our integration code, and that was not always possible to do accurately enough. So there were some cases when continuous collision detection not really helped. And yeah, so the fast bullet would still go through the piece of paper. And next, there was one big problem with it. Like, imagine having a game of billiards where you shoot the ball towards the wall. So you really expect that the bouncing would be physically correct, like the angle before the touch would be the same as the angle after the touch. But that really never happened, so that really depended on the shape types. So if you are thinking about balls, sphere colliders and other sphere colliders, I think it would be working okay. But then there were certain shape combinations that didn't really work. So the good news is that with PhysX 3, we have this changed, and these CCD skeletons are now computed automatically in PhysX 3. So now we get the physically correct bouncing and such. Another thing about bodies is that we had the limitation of 64K on the bodies on the broad face. So this is basically the maximum amount of rigid bodies you could have in your whole scene. So we've decided to raise that, and you can now have about, I think, several 100,000 of objects. But not on all platforms, just on desktops. So for instance, on PlayStation 3, there is still the limitation. And yeah, I always get a lot of questions about that. So no, there is no single constant in the physics code to raise that. It's not like maximum rigid bodies and then an array of bodies and then we could just change that. No, it's not even close. There is some complicated optimizations and there is some bit magic happening. So we can't really pack more objects in those bits. So yeah, it's all about bits. We don't have enough of them on some platforms. Yeah. Next. Another important thing is the mesh collider. So let me just press play. Yeah, this is an old game, quite an old one by Steve Swink. It's called Scale. So in this game, you could basically scale any object, like you could encounter a monster and then scale it up, jump into its mouth and continue the mission in the monster. So you could really scale everything there. But every time you change the scale, we had to create a new mesh with the scaling baked into each vertex, since PhysX 2 did not support scaling for mesh colliders. So that cost memory and performance. The good news is that with PhysX 3, we have it supported, and now scaling is basically free. Well, yeah, except for negative scaling, which is still baked in. But then physics people say that, yeah, they're going to change that and they're going to support negative scaling in 3.4, I think, in PhysX 3.4. And we are on 3.3, so we can have that in the nearest future. Yeah, so now enjoy your scaling. Okay, so now the big changes. So the cloth component. So as I said, we had two components for cloth, interactive cloth and skinned cloth. There was a whole set of problems with that, and I really think that cloth has seen barely no usage over the recent years. Like there were 2 or 3 cases where cloth really worked, but I don't think that much more. So PhysX, they've decided to drop support for something like interactive cloth. So yeah, I'll tell you what is interactive cloth. So interactive cloth is a kind of physical cloth where you could create a cloth piece and then put it into physics scene, and the cloth would apply forces on all of your rigid bodies. Like imagine you have a piece of I don't know, of cloth, and then ball bouncing on top of that cloth. So it comes down, hits the cloth, and then cloth applies some force, and it bounces back. So that was interactive cloth. And it was hugely expensive. It had lots of computational problems. So they've decided to stop supporting that. And yeah, we no longer support interactive cloth as well. But the new cloth is designed with character clothing in mind, so it should perfectly suit your characters. And yeah, again, that was something that most people asked us. Do something about character clothing. So yeah, we are doing something now. And the new cloth is multi-threaded, so we no longer have to create an individual scene per each cloth instance. Yeah, so this is something like a screenshot. So again, this is from 5.0, some early beta. So I can't really say that we will have exactly like this in the final release. We are working on changes and working on changing interface and some integration code, working on fixing bugs. And believe me, there are many bugs here. Okay. So this is something like a curtain-style object. So the way you work with that, so yeah, how do you create curtain-style objects now? There are only 2 things you should add to a game object to get cloth. First is the skin mesh renderer, and then the new cloth component. Now we have made skin mesh renderer to accept regular meshes without any skinning to it. So you can basically add the skin mesh renderer component and then select any of your meshes and drop it in the mesh box, and then you can work with it like with a cloth. So in this example, I've taken some mesh, curtain style mesh, and then selected some vertices which are marked in red and fixed them. And then I can press simulate, and it already works like a piece of cloth fixed on the top, and now it bounces, and yeah, works like that. It's really simple concept. That's it. There are some limitations about the new cloth as well. So first, it's really decoupled from the main PhysX update, so it can no longer apply forces back to the rigid bodies. It's the first thing. And there are certain restrictions for the colliders it reacts on. Yeah, of course, I have not said the important thing about that. So now by default, cloth does not react on any bodies in your world, and you have to specify manually which bodies you want it to react on. You know, that was one of the most expensive steps in the previous cloth to detect whether or not it should react on this object and this object. So the pruning was really, really expensive. So now we have the solution. Yeah, you should manually tell what to react on. And yeah, actually you can only select from sphere colliders, capsule colliders, and then conic capsules. Well, yeah, what's a conic capsule? So yeah, imagine just a regular capsule, but where you could scale the ends. Like a capsule is a cylinder plus two hemispheres of the same radii. And the conic capsule is the same thing, but you can change the radii on the ends. So it's like on the picture. Yeah, and yeah, it doesn't apply the forces back. The conic capsule is expected to be working really cool with the bones. Like if you have arms, and if you look at the arms, they are really like conic capsules. You have it bigger here and smaller here, so it's exactly the shape for the arms. And since we're talking about the cloth for characters, it's all for that. Yeah, I would probably just stop here about cloth, and if you have more questions, just come to Hands-on Lab or ask questions after the talk. So another thing, the wheel collider. So we have the new wheel collider, which comes from the new PhysX vehicles module. And I really think that it is now much easier to use than the previous wheel collider, so now previously, if you wanted to have a car in your project, you had only, I think, 3 choices. You had to just go to Asset Store and download Edis vehicle package, or another package, or the third package, so only 3 choices. I think like that. It was pretty unusable, since in PhysX there was some error about computing tire forces, which really made it super hard to come up with a realistic setup. So Eddie, for instance, is quite a great guy. So he's really good at finding problems and then proposing some crazy workaround around that. And that works. So his package is based around the finding how to work around the PhysX problems. Yeah, now we don't have those problems, and I expect you to go for packages when you want some really finished cars, really tuned super realistically, but not when you want just some car and just something. It could be done with a new wheel collider now. Another thing is that the new parameters in wheel collider are now in real world units of measure. So now you could put mass in kilograms, or I don't know what we use in America, some imperial system, okay, and the same for speeds, for anything else, for stiffness. So you could go to some book and find the simulation data for Formula 1 cars, for instance, and put it there, and it should work without any magic. since we're now using the real-world units of measure. And yeah, as a good addition, we have the new wheel collider, which is helpful for viewing your suspension settings and your steering settings and so on. So I would like to show you a quick demo. Here it is. So this is the truck from the new Edis vehicle package, and it shows you how the new suspension works, how the new tire simulation code works. And yeah, that is all standard wheel collider we have in Unity 5.0 without any magic, no workarounds, no nothing. So just when we have Unity 5.0 released, everyone would be able to go and make the same thing just in 2 hours, I think. But then if you want some realistic settings and you want to tune your car, you would have to still spend time or go for packages. Yeah, that's it. So now we have the code which works with center of mass correctly. It now has code to work with the with friction, with longitude friction, and with lateral friction. It's also really super easy to set up. Just drop a few components. And then, I found out that whenever we have some demo with a car, it's always a four-wheeled vehicle. So I've decided to take a chance and make a demo with some military truck. So this is basically some American military truck with 6 wheels. So the front wheels are only used for steering, but the rear 4 wheels drive. And basically with PhysX 3 you can have up to 20 wheels with each of them driving and steering at the same time. Yeah, and now for something funny. This is some kind of a half track with, I don't know, 18 wheels or so. All of them drive. This is something like a German thing from the Second World War. That's it. So every wheel drives and every wheel applies some engine torque. So yeah, that's it. I hope you like it. Okay, one of the last sections, performance. Yeah, I guess someone is interested in performance. Performance, okay. So I've already said that PhysX is organized in tasks, which really helps us to work with the multi-core devices. Back in the time in the 90s when the PhysX was started, all the processors were just single-threaded, so it really made no sense to create different tasks. But now even when you go and buy some cheap Android device, it already has a few cores, so you have to be aware of that. Another thing is that on Android we use the Neon instruction set natively. So on Android we expect to get some performance boost because of that. Then it's not going to be available for Unity 5.0. I think it will be in 5.1 or 5.2, but yeah, really soon. We are going to enable the GPU acceleration. So unfortunately, that only works for cloth now. And also it only works on NVIDIA hardware since it's based around CUDA. And CUDA with PhysX works only on Windows and on Linux. So we have some experimental code to run that on Mac, but it doesn't still work quite right. So it's not still there. And also it doesn't work on consoles. So yeah, that's it. But we'll have it really soon. Next, PhysX 3 has better algorithms. So as I've said, it has taken some best approaches from the previous PhysX. But because of the cleaner code base, because of new algorithms to handle pruning, to handle sleeping, to handle your queries, it is now much faster. And if you are interested in numbers, you should totally go to physixinfo.com, or you should go and find Pierre Tiedemann blog. It's called Code Corner. So Pierre is one of the core developers in PhysX. So he has made a post about comparing PhysX 3 performance against PhysX 2 and Bullet as well. So if you go to that site, you could really find more data, like a lot of charts to compare this case and that case. So go there and figure out. But for those not really interested in going to websites, so looking at different projects, we can say that PhysX 3 is 2 times faster on a generic scene. Yeah, that's also good. But if you have some specific cases, you could have up to 10 times performance boost. So yeah, but that's only for some cases. In the most generic scenario, you can have 2 times, which is also pretty good, 2 times faster on the same machine. Good. So yeah, the diagrams I have is for 2 cases. So yeah, physics is all about cases. So some cases work fast, some cases work slow. So the case on the left is all about having the pile of objects, one on top of another, and you can see that. What you could see? Yeah, you could see that it works approximately 2 times faster, the new PhysX in that case. And it doesn't depend on the simulation time. So we start simulating, and yeah, piles are approximately simulated like before, just they've dropped something from the beginning. But the next case is all about dropping some spheres on top of a mesh, like when you have some characters placing on the terrain or so. So this case is much faster now, especially in the beginning when you have context. So context processing is much better, since in this case you have some spheres created in the air and then they fall down on the mesh. So there are a lot of context generated at that moment, and this is why we get that huge spike there. Okay. Yeah. So on the vertical axis, we have the simulation time with every frame. So we have frames, and then we measure how long did it take to simulate the frame. So the higher the graphic, the worse it gets. Yeah. So having a low value is always best, since you simulate frames faster. So the graphic on the right, you have some really long frames in the beginning in the PhysX 2, but then it goes down. And with PhysX 3, we don't no longer have it. It works fast right from the beginning. Yeah, so let's go for summary. So yeah, PhysX 3 is 2 times faster. Now we have some multi-core support, which we hope to help you with your performance problems. Then we have fixes for long-standing issues for scaling mesh colliders, for instance, for wheel colliders, for moving static objects, and so on. Then we have new modules, the new wheel collider, which is hopefully better than we had before. And then we have the new cloth designed with character clothing in mind. Yeah, and then we have compatibility issues, of course. And yeah, thanks for coming. That's basically it. Yeah, so catch me at the hands-on lab area downstairs if you have any questions. And now we have some time, and if anyone has questions, I don't know how to do it best. You can just ask it now, or come after the talk, or catch me at hands-on area.
You mentioned that the moving static colliders is basically free now. Does the collision do you still get discrete collisions on moving static objects, or is it still better to put a kinematic bridge body if you're going to move the object?
Yeah, you should certainly put kinematic.
Okay, all right.
Yeah, any other questions? Yeah, go ahead.
Are you going to, right now with the new framework, can you do stuff like check collision on a convex mesh collider in code before you place it somewhere, for instance? Or do you have to do your own try check, like your own collision checking still?
I think there is a method to do that. There is, but I'm not sure for convex meshes. So there is a method, PhysX.check something. Catch me at the hands-on lab area. I'll figure out. Anyone else?
You haven't. Sorry.
Any plans to include the PhysX destruction module or true soft bodies anywhere in the PhysX cycle?
Good question. Yeah, I have nothing to announce now. So yeah, actually we are looking into integrating Apex Cloth, but I'm not sure we'll do that. Probably we'll end up with our own integration code. And then we'll see about Apex destruction, if you're asking about that. Yeah, so we'll see about that.
Cool, okay.
It's not there, it's not for 5.0 certainly.
Sorry, here. You haven't spoke about joins and configurable joins and everything. Is it something that's been improved as well?
I'm not sure I fully understand the question. So yeah, we have the configurable joins now. I'm not sure we got so much improvement in configurable joins since PhysX 2. So there are certainly some changes. They work somehow, yeah. I don't have cases, to be honest, on the new configurable joins. So if you have a case that doesn't work really right, if you're talking about that, so just file a bug, please, and I will make sure it is fixed within new PhysX. If you could just do it, it would be really nice. Anyway, I'm not aware of the bad cases there. And about the joins, I think another important question people ask is whether or not we are going to expose other types of joins, like PhysX has artificial joins. No, not with early 5X. Probably a little bit later, yes. We know about that and we are looking into it. It's on the radar, but it's not due to be released right now.
What kind of joints you say? Artificial?
I have to figure out the exact spelling. I think it was artificial joins, but yeah, I'll figure out later. There was some kind of a join to help you work with the characters. It was like something like that, like configurable join but for characters. Yeah, next question.
Is there any exposure for like an asynchronous raycast that can be done at some point in the framework? So if I don't need the result right away?
No, not yet. Not yet. So PhysX has support for that. They have px batch query, but we don't expose that yet.
So no more terrain collisions is kind of a big change to our workflow. So what's that?
No, not exactly like that. You can still have terrain collider, but you can't have triggers on it. But you can still drop your objects on top of the terrain collider, certainly. It's based on the height map internally, so it works pretty well.
What if you use something like terrain for mobile or something like that? If your terrain's really a mesh?
What?
Are you familiar with that product? You know, a lot of us, especially on mobile, we convert the terrain to it's a mesh. It's
Yeah.
traditional geometry.
Yeah, okay.
Just trying to figure out what's going to happen to me now.
So yeah, when you convert your height map to a mesh, it's still concave mesh, right? So you can't have a trigger on that. But you can have collisions, of course. So if you make your terrain a static collider or a kinematic one, you can have a concave mesh there. It's pretty okay. It's supported. So no big news there.
Excuse me,
Yeah. Who was that?
over here.
Yeah, go on.
So are there any implications for the performance of generating colliders at runtime from procedural geometry, or and with the new job system that we've been hearing about, is there any opportunity to enable async creation of colliders from procedural geometry?
Yeah, not yet.
Okay.
If I can follow that up, I'm doing the same thing, and I notice a little bit of overhead, a little bit of a hit every time, for each chunk of terrain that I'm sending into the physics system, if you will. So I have to be careful about how many I send in at any given time, kind of space it out. Is that going to get better?
Let's have a look. Let's have a look. If you could find me at the hands-on lab, we could make some scene, and then I could work on that later. Or just take my business card and send something. I will play with that and write you back. Yeah, next one.
Any change in the vertex limits for rigid bodies or meshes?
What kind of limits for convex mesh? Yes, it's still there. That is something that is in PhysX. It's not my limitation in integration code, unfortunately. I would certainly raise that. Any else?
Yeah,
Let's do there.
At the minute, the physics collision layers are tied into the same system as like the camera filtering and light layers. Is there any plans to separate those out? Issues with the number of layers to get all the permutations of things?
Oh, I'm not sure I hear you quite good. So the filtering is still there, and yeah, it's still based around the layers. And then I didn't hear the rest.
So that's also the same as the camera visibility layer as well. It's the same system. So if you're using one to determine, I don't want this in this camera, you've also then got a set of physics layer. You see what I'm saying? You've got a permutation issue where you're I want this in this camera, I want it to only collide with these objects. You're using the same system for that, you need to separate those out.
Yeah. Let's talk about that at the hands-on lab. Yeah, sure, but then we have some questions over there. Someone from the... Yeah.
My question is simply this. So for the parallelization of the colliders,
Yes.
generation, if I have 1,000 objects with simple colliders on them, Unity 5 will automatically parallelize the collider collision between all those objects. I don't do anything special about it. It'll just happen.
Do you mean creating? Like...
No, just if I have a huge scene with, say, 1,000 colliders on it,
Yeah,
flying around, simple colliders.
yes.
And right now it's CPU limited. With Unity 5, it'll scale across all the cores automatically.
Yes, it's expected to do that. So we have it designed in task-oriented way. So there would be one task to simulate each body. So I think it should improve. But we can check. I have a build of 5.0 with me. If you catch me at the hands-on lab and bring a project, we could see how it goes. That would be the best we could do now. Yeah. So he's gone. He's gone. So you decided to move on the right. That's Unity, people. Fantastic. Yeah. Go on.
So for the cloth, is it support like breaking parts of the cloth apart, like?
Yeah, like tearing cloth. Yeah, no.
Or like subdivide a cloth? Is there any programming that would do that, or?
No, I don't think so. You couldn't subdivide that. No. Not yet. But probably, let me think. Catch me at the hands-on lab. I think we can do that, actually. Yeah. You can hack around, so you could, there is, so the way cloth works, there is the original mesh, and then we create a particle, cloth particle per each vertex of the original mesh, and then we have the whole handful of parameters. Like we have the maximum distance parameter. So in the example with the curtain, you could fix the top particles, and then look at some particles in the middle and fix them, or make them free, basically. So I think that could work. You could hack around, I think. Yeah, we could do that. But we don't have tools exactly for that. Any other questions now? Oh, one question. Yeah, let's go.
Is this all deterministic?
Haha. Yeah, so we expect it to be more deterministic than before, and I've been talking to NVIDIA about that. So now they say that it's all deterministic. I think that is close to that, but I'm not sure when we add the GPU support, how would that work? Actually, it is one of the concerns why I decided not to include GPU support with 5.0. We really need to see how it works. I think it should be deterministic. But if you're talking about getting exactly the same results when you simulate on Android and on Mac, for instance, it's not always. You know, since you use different processors, you're bound to have different results, I think. But when you simulate on the same processor, it should be deterministic. I don't know how much time we have. It should be 6 minutes or so. 5 minutes, okay. That should be 5 questions, okay. Let's go.
Will this work on WebGL?
Yes, it works on WebGL now. So unfortunately, we don't have threads on WebGL, as you know. So the task-oriented design is not still there. But anything else? Yes, the new wheel collider, the new cloth. And what else? Well, basically everything else. Yeah,
More of a request, essentially, was saying, just the layering, having the physics layers be separate from the camera rendering layers for like pulling off and stuff like that. I think would be pretty.
Let's talk about that later. I need to understand what is the use case for that, but I think we can do that.
Or just running out layers. Like if you only have 32 layers, right? So if you want more layers, or if you want to keep the lighting and just all the stuff run out.
Okay, I see. So more layers.
More layers, or just having separate layers for camera versus.
But what if we increase the amount of valuable layers? Like now we can have 32 layers, but what if we make 64 layers? Will that suit your needs?
I mean, it helps in one sense, but what if you have an object that needs to have some sort of physics interaction?
Yes.
One layer, and also some sort of camera pulling or rendering issue on the same camera, right? So you only have one layer, and it's doing both the physics thing and the camera thing, which is kind of weird. Use case.
Yeah, I think we should consider that. Not for 5.0, but probably in 5X. Let's stay in touch, and if you poke me sometime in the future, that would be best. Okay, good. So, who wants to ask questions? Anyone? Yeah, you go.
So we don't have interactive clothing or one like force. Is there, how do we overcome that? Can we detect the collision with the cloth and slow it down manually by adding force? Or how would we do the simulation you talked about where the ball onto the cloth?
Well, I would say it's up to you. It's the best I could say now.
Will it be collision? Will it be able to get a trigger on a cloth? Or
Well, I don't think we send it now, but we could probably fix that. Yeah, we need to do some testing for that. Yeah, I can imagine that as an important case, but then I think there were quite a few projects doing exactly that. And most of the projects wanted to do just cloth, so we concentrated all our efforts on the new cloth component for character clothing. But then I could say that for 5X, we are really working on cloth, and we are going to have more changes in cloth, and yeah, who knows? So for instance, we are going to have this nice thing to integrate mechanism avatar with the cloth. So when you have a character and that has a mechanism avatar, we would use the bones to create the colliders automatically. It's not in 5.0, but for 5x we are going to do that. And all you have to do is to just add some piece of clothing, and then it will react on the bones of character. That will happen automatically. This is just one example of what we are having in mind and working on. Yeah. I don't know how many? 1 minute. Let's do last question. Yeah.
So when you showed that lion that was broken up into the convex mesh pieces
Yes.
for collision detection, do we have a tool set that automatically does that?
Good question. So I'm planning to include the tool set with 5x. So 5.0, no, but with 5, I can't say how, 5.2 probably, but maybe 5.1. We are going to have HACD library integrated that would take your concave mesh and automatically decompose that into convex colliders, like on the slides.
Does it do that based on the bone rig that you have?
No. It just takes your mesh and builds the convex hull, and then it has some settings like concavity. You set the concavity, and that basically restricts the maximum concavity of each individual cluster. So yeah, that works. Yeah, I have a branch with that working, but it's not in the main line yet. That's mostly about testing and merging stuff, so it's there. Yeah, so yeah, that was the last question. I hope you've enjoyed the talk, and yeah.